Hello students, today we're going to look at 6.2, which is all about slope. Now in the last video you looked at constant rate of change, and I'm going to tell you that constant rate of change and slope are exactly the same. They call them different things because they're used for different purposes. But when we talk about lines and graphing lines and tables and stuff, we call it slope. Now what is slope? Slope can be defined as the steepness of a line. Okay? The steepness of a line. How steep is the line, or how not steep is the line as we look at it. So there are two ways that we can find slope. And one way that we can find slope is by looking at 2 points on a graph and figuring out the rise over the run. Now think about that just a second. Because when we did constant rate of change, we did y over x, and y is going up and down, which is rise, and x is going across, which is run. So to find slope, we do rise over run. So I have this graph here, and I've got a line, and we're looking for rise over run. Now you don't have to draw the whole graph, but if you'll just draw the x-axis and the y-axis and draw a line that kind of looks like mine, that'll help us, and then we'll look at the numbers that I write on here, and you can write those as well. So I'm going to start at my lowest point. Okay? My lowest point is this one. So I typically want to start with the lowest point. It's a little bit easier to figure it out that way. So if I start with my lowest point, I'm going to see how many places do I have to rise in order to get to the same line where this other point is. So I'm going to go 1, 2, 3. And since I'm going up, it's positive 3. And now I'm going to go to the right. How many places does it take to get me to that other point? 1, 2, 3, 4, 5. And since I moved to the right, then it's positive 5. So if I'm doing rise, from the bottom point, I rose 3, and I ran 5 to the right. They're both positive. So my slope is 3 over 5. Now some of you might want to take that fraction and say, oh, I have to turn it into a decimal. No, you don't. We want to leave it as 3 over 5. That's the rise over the run. Because what I can do with that slope now is I can go from this point and find another point on the line. If I go up 3 and to the right 5, there's another point on that line. And it works going both ways. Well, that last example was so much fun. Let's do another one. So I have another line, if you will, for example number 2, draw the x-axis and the y-axis and draw a line that's going down. We're going to look at the slope for this one, or how steep is this line. Again, we want to start at the lowest point. In this case, here's my lowest point. So let's figure out what my rise over run is. So I'm going to do rise over run. So I'm going to start here, and how many do I have to go up? 1, 2, 3, 4. And so I'm going up. That means it's positive. So we know our rise is 4. Now I have to run 1, 2, 3, 4, 5, 6. But since I ran to the left, that makes it negative 6. So my slope is 4 over negative 6. Now you can see that that's not in simplest form, and our fractions always need to be in simplest form. So we're going to reduce this or simplify it, and we know it's going to be negative because one of those numbers is negative, and I like to put the negative on the outside. So I know that is negative, but 4 over 6 simplifies to 2/3, so the slope equals negative 2/3. Again, you don't have to, but I strongly suggest that you start at the lowest point, go up 4 to the left 6 to get to the next point on my line, and that's my rise over run. Now there's also another way to find slope if we're not given a graph. Let's say, for instance, we're given a table, or we're given 2 points. And so I'm going to say we're given the points 3, 5 and 2, negative 1. Okay? And so they want to know, what is the slope of the line that passes through these 2 points? Well, there's a formula for that. And the formula is m And m is slope. I forgot to tell you that in the earlier part of the video. M is the letter that mathematicians chose a long time ago to represent slope. So m equals y2, and notice the 2 is just a tiny 2 down here at the bottom of the y, minus y1 over x2 minus x1. Now those 2's and 1's are only identifiers. They don't have anything to do with the formula. They just let us know I'm looking at the second y and the first y, or the second x and the first x. So here's my formula. Write it down, memorize it. We're going to use it a lot. So now I have to go up here to my 2 points. I know this is x and y and x and y. And I get to choose which one's y1 and which one's y2 and which one's x1 and which one's x2. So I'm going to call this as x1 and y1. And this will be x2 and y2. Because this is the first point, x and y, that's what the 1 is for. This is my second point, x and y. So now we're just going to take these numbers and plug them into our equation, or formula. So m equals, y2 is -1 minus y1 is 5 over x2, which is 2, minus x1, which is 3. And here's where we get our handy-dandy calculator out, because you need to calculate these. -1 minus 5 is -6. 2 minus 3 is -1. If you don't trust me, do it on the calculator. So now I need to simplify. I know it's a negative divided by negative, so that's going to make it a positive answer. And since I can't simplify anymore, the answer is going to be 6 over 1. So the slope of the line that passes through 3, 5 and 2, -1 is 6 over 1. Now just to help give you a little bit more background on this, if I was to plot these 2 points on a coordinate plane, then I would have to go up 6 and to the right 1 to get from one point to the other. So let's do one more example of giving you points and then finding the slope from those. So let's say my points are 0, -4 and 2, 5. Okay? First I need to identify which one's x1, y1, x2, y2. So we're going to call this an x1, y1. And this is going to be x2, y2. Now you can pick whichever ones you want. If you want to switch them, you can switch them as long as both of these are 2's and both of those are 1's. So let's remember the formula. M equals y2 minus y1 over x2 minus x1. So now let's plug in. y2 is 5 minus y1 is -4 over x2 is 2 minus x1 is 0. I forgot my m equals. 5 minus -4 is +9, because minus and negative is the same as plus. And then 2 minus 0 is 2. So my slope is 9 over 2. I don't need to change it to anything. I leave it as 9 over 2, because that's my rise over my run. Now let's do something real quick. Let's put these in an XY table. And I have 0, -4, and 2, 5. Let's do our constant rate of change and see what happens. To get from -4 to 5, I have to add 9. To get from 0 to 2, I have to add 2. So when I do my y over my x, I get 9 over 2, which proves to me that constant rate of change is exactly the same thing as slope. So here are your practice problems for today. There are 2 of them, and all I want you to do is to use the formula to find the slope of these 2 lines. For number 1, my points are 4, 1 and 2, 6. Use the formula, plug it in, find the slope. Number 2, my points are 3, 0 and 0, -5. Plug those into m equals y2 minus y1 over x2 minus x1 and find the slope. Take a picture of your practice problems and submit it through Edmodo.